Hi, this is Finio with Let's Go Boys and Girls, and this video will serve as an introduction to the various tools you will be using in our electronics course. Okay, so the first three tools we're going to go over are our needle nose pliers, our diagonal cutters or wire cutters, and wire strippers. Now, these two on the left here are pretty simple, and these are probably the ones you're most familiar with. Needle nose pliers are nice for just gripping tiny parts, or if you need to twist something that's hard to grip with your fingers. And they usually also have a cutting surface that you can just use to snip off pieces of wire. So if I bring my spool of wire in here, you can see I can just use that back cutting surface to snip that off. And then the wire cutters or diagonal cutters don't have a gripping surface, they only have a cutting surface, so you can use those to just quickly snip bits of wire. Now, the tool you're probably less familiar with is wire strippers. Now, this is kind of looks like a pair of pliers, but if you look closely, you'll see it actually has a set of tiny holes with numbers next to them, and those numbers correspond to wire diameters. So wire comes in different sizes, and that wire is usually insulated with rubber, and if you want to connect this wire to something with soldering or alligator clips or something else, which we'll talk about later, you need to strip the insulation off a little bit of the end. So most of the time, you're going to be working with 22 gauge wire. That's usually the most common gauge for projects like these. So if you look at the scales on the wire grippers here, you see one side is in AWG, that stands for American Wire Gauge, and then the other side is in millimeters. Now, the American Wire Gauge system can be a little confusing because a bigger number actually means a smaller diameter, but don't worry about that too much. Just look for the 22, and then what you do is just pop open the lock that keeps these closed, and then they're spring loaded so they push open automatically, and all you have to do is take one of your pieces of wire that you cut, feed it into the hole that was labeled 22, and give the wire a nice gentle tug. You don't have to pull very hard, and you see that the insulation comes right off there, and now I have an exposed metal section on the end of the wire. So pretty simple to do. You can also usually use these to cut, so they have a cutting surface on the back. So if you need to cut the wire to length, you can do that, and then use them to strip the end. So really, you can get away with just the wire strippers, but the needle nose pliers can still be handy for gripping things, and then diagonal cutters, if all you need to do is cut and you don't have a pair of wire strippers handy, those will work. So those are your three basic tools for dealing with wire, and next we are going to talk about soldering. Okay, next we're going to talk about soldering, and I've intentionally committed a major safety violation here because I want to emphasize this point. This soldering iron is plugged in, and you should never, ever, ever leave a soldering iron that's plugged in just resting on a table. This is both a fire hazard and a burn hazard. Okay, the tip of this soldering iron is very hot. It will burn you if you touch it, and if you leave it sitting on a desk where there's papers or other things sitting around, it will catch them on fire. That is why you have a soldering iron stand. This stand is just a metal coil that you can safely rest the soldering iron in so that the tip is protected from touching things, including burning people and catching stuff on fire. So this is something very important to keep in mind if you're doing the soldering yourself, and especially if you're teaching your students to solder. Kids, they might get busy, they will get excited about running off and working on their robot or something and just leave the soldering iron sitting there on the table, and then the next person could come up and not see it and bump into it. It's very, very important to emphasize immediately with the kids if they're doing the soldering that they always put the soldering iron back in the stand. So, assuming you have everything set up properly and safely, the purpose of a soldering iron is to melt solder, which is this strand of very soft, flexible metal, so you can fuse different parts together to make an electrical connection. So I have two things as an example here. This motor, you can see this is a little DC, meaning direct current motor with a shaft that spins when you apply a voltage to it, but this motor did not come with any wires attached. It just has these two little tabs. So if you buy something like this that does not have wires attached, you will need to solder them on yourself. That's in contrast to some things like this battery pack, which when purchased came with two wires already attached, so you don't need to solder wires onto something like this. And I'm just going to use the motor as an example of what to do. I have two sections of red and black wire here that I've already stripped using my wire strippers that you saw in the previous section. And normally it's easiest if you can somehow link the two things together mechanically a little bit before you do the soldering so that it's easier and you don't need a third set of hands to hold them in place. So since you can see these tabs have little holes in them, I find it easier to thread the wire through that hole and then bend the wire. Sorry, let me get this in front of the camera so you can see it better. Thread the wire through the hole and then bend the tip of the wire a bit to hold it in place. So you can see I threaded the wire through, and now I wrapped it around so I can let go and the wire isn't going to fall off. And then I'll do the same thing with the red wire. And you'll remember in the last segment of the video I mentioned the needle nose pliers. If you're like me and you have big clumsy fingers, this can actually be a great place to bring your needle nose pliers in and use them to grab onto that tip of that wire and wrap it around nice and tight so that it doesn't fall out. So now you can see I've got both of those twisted around. They're dangling there, but that isn't very good for an electrical connection because as this wire jostles around, it could actually lose contact with that tab, and then your motor will stop spinning. You don't want that to happen. So what you want to do is take your soldering iron and take a bit of solder. The solder is usually flexible enough that you can just yank it and break it, but if you have trouble doing that, you can also just use your wire cutters. And now you bring your soldering iron and your solder to the metal part. Heat the metal part with the soldering iron. This can be a little difficult to do if you have something like a motor that's rolling around. You'll see a little smoke coming out, but that is okay with lead-free solder. So you'll hear some people argue that leaded solder is easier to work with because it flows better, and that beginning solderers should learn to solder with leaded solder instead of lead-free solder. We think we're going to err on the side of caution, especially working with children, and use lead-free solder instead because we don't want to worry about lead poisoning. So even though it's a little more difficult to use, we're going to be supplying lead-free solder with all of our kits. So I'll come around, bring this up to the camera. You can see now there's this little bit of melted solder that's holding the wire on there nice and tight. So if I shake it, the red wire isn't as loose anymore, but the black wire still is. So I will try to zoom in a little better this time. See if my camera wants to focus on that. Not quite. See if you can see the second one a little better. So there's the wire wrapped around that tab. I'm going to come in with the soldering iron, and you'll see a little bit of smoke start to come off as the solder's melting. And you don't need to go overboard, you just need enough to hold it there. So now you can see I have a nice little shiny solder blob on each one of these, and it doesn't actually look like the black one bonded onto the tabs. You can see how I got some solder onto the wire there, but it's still sliding around. It didn't actually connect to the tab. So there's absolutely no harm in just going back in there and heating it up again and using the tip of the soldering iron to spread the solder around a little bit to make sure it makes good contact with the tab. And if you need to, you can always go back in and add more solder. So now I'm going to take a second to zoom out again. I have a motor with two wires soldered on. So the other thing you may encounter is needing to solder two wires together. So say I have my motor here, and I need to connect the end of these wires to the battery pack. So I'm going to use my wire strippers to strip off the ends of these wires. Now I'm going to bring in my battery pack from earlier, and I want to have black to black. Black stands for negative, red stands for positive. I want to connect the red wires to the black wires somehow. Now the easiest way to do that is to take the ends of the wires and twist them together. And if you don't have a soldering iron available, this will work in a pinch. You can just twist them together and rely on that. But again, you want to have a stronger electrical connection, so it's better to use solder when possible. So now I have those two wires twisted together. I'm going to again come in with my soldering iron, heat it up right by that wire, and now I have a nice little solder connection holding those two together. I can do the same thing with the red wire. I actually have my battery pack on so you could hear the motor starting to spin there. So here I'll try and zoom in again. There's the ends of the red wire. Oh, see, I didn't do a good enough job twisting there. So again, no harm in just twisting those up again. Make sure they stay together so you don't need to hold them in place while you're using the soldering iron. Come in with the solder and the soldering iron and just heat that up. And there we go. I now have a nice little blob of solder holding those two bits of wire together. And now I have my motor soldered up to my battery pack, and if I flip the switch on the battery pack, the motor starts spinning and I'm all set. The last thing you'll want to do is clean the tip of your soldering iron off. That's what this sponge is for. Your soldering iron stand should come with a sponge that you need to get damp with a little bit of water, and you can just use that to clean off the tip of the iron. You want to do that because if the tip gets dirty and accumulates a lot of dirt, over time it'll become more and more difficult to use, and eventually you'll have to replace it. So this is another good habit to instill in the kids if they're using the soldering iron, to make sure that they clean it after each use. Kind of wipe it in the sponge and roll the tip around. And then when you're done soldering completely, cheap soldering irons like this don't have an on-off switch, so you just have to go unplug it. There are more expensive soldering irons, like this one I have sitting over here on my bench, that have a on-off button and an adjustable temperature knob, so you can turn the temperature up and down depending on what you're soldering. Some very sensitive things you don't want to go too hot because you could damage them, but that isn't usually going to be a problem for the types of projects you're working on. But if you are planning on really doing a lot of electronics projects in the future, a soldering iron like this for about $50 can be a really worthwhile investment, as opposed to one of the cheaper ones like this that's about $10. But again, if you're just starting out, this $10 one will certainly get you by. So now that you know how to use your basic wire strippers and pliers and have had an introduction to soldering, next we're going to talk about using a multimeter. Okay, and finally we're going to learn about using a multimeter, which is a device used to make measurements in electronic circuits. Now, a multimeter might look a little intimidating if you've never seen one before, but because there's a lot of different settings on the front. But I don't want you to feel overwhelmed. We're just going to go over the two most common uses that you're going to encounter with a multimeter for basic electronics projects, and then in the future, if you do more electronics classes, you're going to eventually learn about all these other settings. But don't feel overwhelmed for now. We're just going to go over the very basics here. And the way you make measurements with a multimeter is with probes. So you see here a red and a black wire that I'm going to untangle. One end of the probe is called the probe tip. This is what you poke at what you want to measure with. If you're measuring a circuit or a battery or something else, and normally they're pointy. I have actually managed to break one of my probe tips with a previous project, so that's a lesson to never poke something or try to use these like a screwdriver or a tool to pry something, because the tip actually isn't that strong. It's just meant to make electrical measurements and not really to exert a lot of mechanical force. You can see I learned that the hard way. And then the other side of the probe looks like this. This is called a banana jack, and this is what gets actually plugged into the multimeter. So if I bring my multimeter over, you can see it has 3 ports on the front. And again, don't worry about exactly what all these symbols mean right now. Right now you just need to know that black gets plugged into the port called COM. COM stands for common, which is another way of saying electrical ground. And then for the vast majority of what you do, the red one is going to go into this one on the right that says MAV and then capital Omega, which is a Greek letter that stands for ohms, which are used to measure resistance. We're not going to get into that now. This other port that says 10A, that 10A stands for 10 amps, which is a very high electrical current, but the vast majority of what you measure isn't going to have this high of a current, or even if it does, you're not going to need to measure it. Usually you're just going to be measuring voltage, which is what the V stands for, so your red probe is going to go over here. Now, I just mentioned measuring voltage. The most common thing you're probably going to do is just use a multimeter to see if batteries are dead. So if you have kids who say, my robot's not working, something's not working, and they've really tried everything else, and you're not sure if the batteries are dead, or if they've done something else wrong, you can use this to check, and you do that. Over here on the right, there's a V with a solid and a dashed line next to it. That stands for DC voltage, meaning a constant voltage that's output by a battery, as opposed to AC voltage, or alternating current voltage, which comes out of a wall outlet, which alternates back and forth 60 times a second. So you definitely don't want to use one of these to measure a wall outlet. That's dangerous, but it's perfectly safe to use them to check batteries. So you can set it to the approximate voltage that you think you're going to measure. For example, a single AA or AAA battery outputs 1.5 volts. So if you're only measuring one battery, this has a 2 volt setting. So that's a little bigger than what I need to measure. So I'm going to set this to 2 volts, bring in a AA battery, and then I'm just going to poke the terminals on each end of the battery with the probes. And you can see I'm actually getting a negative number right now because I have the black probe on the positive side of the battery. So I can switch those around, and I'll get a positive number. And I'm getting about a little more actually, 1.6 volts, which means this battery is perfectly healthy and there's nothing wrong with it. So you are also frequently going to encounter battery packs that have more than one battery. So this has 3 AA batteries inside, so it should be outputting about 4.5 volts. But you'll notice now I just have these flimsy little wires on the end, and it can be a real pain to get your probes in nice contact with those wires. So even though it looks like I'm pressing on them right here, I'm actually not getting much of a reading, and that was actually because I didn't have my battery pack on. So let's see. It's an important thing to remember. If you're testing a battery pack, make sure you turn it on. And now I can make contact with these wires, and you can see I'm getting a bit of a reading on the screen, but it's bouncing around a lot, and that's because my probes aren't making consistent contact with these wires. So in that case, this is where alligator clips come in really handy. These are nice little clips. They're called alligator clips because they resemble alligator jaws that let you latch onto something, and then you can use your hands to do something else instead of trying to hold the probe tip steady, and it makes life a lot easier. So what I'm going to do is unplug my probe tips here, and then you see my alligator clip cables work just the same. They have a banana jack on one end and an alligator clip on the other end. I'm going to plug these in to my multimeter and then just clip the ends on to the wires from my battery pack. And now you see I'm just getting a 1 on the multimeter, which is a little strange. That's because I don't have the range properly set. So when it's set to 2 volts, the highest the screen can display is 2 volts, but I mentioned earlier 3 AA batteries does 4.5 volts. So you'd run into the same problem, for example, if you were trying to measure a 9 volt battery. I need to go up to the next highest range, which is 20 volts. And now you can see that I'm getting a nice steady 4.7 volts, and I don't have to worry about the probes coming loose, and I have my hands free to do other things like adjust the settings on the multimeter if I need to. So remember, don't worry about what all these other symbols mean. When you need to measure voltage, just look for the DC voltage settings, which are usually a V with a line next to it, and select the next biggest voltage from what you expect to measure. And in most cases, with the projects you'll be doing, that's either going to be 2 volts or 20 volts, depending on the number of batteries. Now, the other common use, again, if kids are coming up and saying, mine's not working, but you've tested the batteries and the batteries are good, is to look for a loose connection somewhere in their robot. And you can do that visually by looking for wires that aren't touching each other, or maybe a wire that isn't properly connected to a motor. But sometimes you can't tell just by looking at it, and you need to know electrically as well. And you're going to do that by using a continuity test. The continuity test is this little symbol here that kind of looks like a speaker. It's kind of these 3 little parallel arcs. So when you set the multimeter to measure the continuity, you do the same thing. You just plug your probes into the same ports. And now, when you get an electrical connection, the multimeter is just going to beep. So if I take my 2 alligator clips and bump the ends together, you don't really have to worry about what it's displaying on the screen. That's actually a resistance value. But if it's effectively 0, meaning a very low resistance, you just get a beep. So, say if I have 2 wires that I've twisted together like this, and I want to make sure that these wires are connected, I'm just going to clip my alligator clips onto the ends of them, and I get a nice consistent beep. But if I if kids have twisted these wires together and maybe not done a good job, or they didn't solder them properly and the wires get jostled around over the course of their robot operating, eventually these might come loose and then you won't get the beep. So you can see if I have my alligator clips clipped onto both ends of the wires and these are touching, I get a beep, but when they come loose it stops beeping. So those are the two most common things to check if a kid come up and says theirs isn't working. Make sure the batteries aren't dead, and make sure they don't have misconnections somewhere with wires that might look like they're touching but not actually be electrically connected. Okay, so that has been an introduction to the most common tools you're going to use in your electronics course, and now you can move on to the videos that actually describe the activities. Have fun.